So now we'll discuss about concept of pointers. Okay, so let's write pointers. So what is meant by pointer? So the basic definition of pointer is it is a variable which stores the address of another variable. Okay, so variable which stores the address of another variable, which stores address of another variable. Okay, so in pointers, in order to declare a pointer variable, we make use of star, which is a operator to denote it is a pointer variable. Okay, I'll show you the syntax for declaring a pointer. So I can write multiple syntaxes. First one is how you're going to declare a pointer. Okay, a single pointer. It means here, first of all, you need to mention the data type of the pointer variable, give space, and then write name of the pointer variable, that is variable name, and then semicolon. Okay, so this is how we can declare one pointer. Okay, so next, similarly, if you want to declare multiple pointer variables, in that case, you can write like this, that is data type multiple pointer variables. So star variable 1, star variable 2, and so on, star variable n. Okay, here also star variable n. So like this, we can define multiple variables under a particular data type, and all these variables are pointers. Okay, pointer variables. So now I'll show you an example for defining a pointer. Okay, so consider an example, int a is equal to 10. Okay, this is a variable, right? This is how we generally define a variable. Now we can define a pointer here, that is a star ptr. Here ptr is a pointer variable. Okay, so ptr is equal to address of a. Ptr equal to address of a. Then now you can actually print content of variable a using star ptr. Okay, just like this. So let me explain how this is going to work. First of all, int a is equal to 10, which means a is a memory location and its value is currently 10. Okay, so and then consider the address of the variable a. For example, it is located at 2000 memory location. Then ptr equal to address of a. Ptr equal to address of a. What is address of a here? 2000 is a memory location. Now ptr is clearly pointing to this memory location. Okay, so now you're trying to print a star ptr. What is meant by star ptr? Star of ptr value is how much? 2000, which is a memory location, isn't it? So star 2000 is nothing but contents inside 2000 memory location. Contents inside 2000 memory location. So what is the content inside 2000 memory location? Clearly 10 is the value. Yes or no? So 10 is the content inside 2000 memory location. Hence the output that is displayed by this particular code is 10. Okay, like this. Now similarly, we'll consider another example. where I'll show you a character pointer. Okay, so example number 2, and here consider a character data type variable. Okay, char ch is equal to y. Okay, y for indicating yes, n for indicating no. Okay, so now I'll take a character pointer like char star ptr. Okay, now ptr is equal to address of ch. Now we can print with the help of star ptr, that is percentage %c star ptr. Clear? So again, let's see how this is going to work. Similar to the previous example, here also char ch is equal to y. It means it is going to create a memory location which is ch, and it is storing y inside ch. Okay, so consider the memory location of ch is 3000. Okay, now we are declaring a pointer variable which is under character data type. So ptr is the corresponding pointer variable which is holding the address of ch here. You can see ptr equal to address of ch, which means 3000 memory location is stored inside pointer variable ptr. Okay, so finally we are printing percentage %c star ptr. So star ptr is nothing but here it is star of 3000. So star of 3000 means contents inside 3000 memory location. So y is the content that is stored inside 3000 memory location. Clear? So immediately it is going to display y. Okay, so now we'll consider an example related to these pointers. Okay, with a small program. For example, like this. Consider including the header file first, stdio.h. Okay, and now in the main function I'm considering two pointer variables and two normal variables. Okay, a is equal to 10 and b is equal to 20. These are normal variables. So now I'll consider the pointer variables. Int star p1 is equal, okay, int star p1. Later I will initialize. The other one is star p2. Okay, so consider p1 equal to address of a and p2 is equal to address of b. Okay, so finally we will print like this: printf percentage %d star p2 minus star p1. Okay, so let's see what is the value displayed by this particular code. What is the output that is displayed here? So you can observe, first of all, the moment you write a is equal to 10 and b is equal to 20. Okay, so clearly a is a memory location and it is currently holding a value of 10. Okay, then b is another memory location, it is holding a value of 20 currently. So p1 equal to address of a. Let us suppose address of a is 2000 memory location and address of b is 3000 memory location. Okay, so p1 equal to address of a, which means p1 is a pointer variable which is holding clearly the address of a, this one. Next, p2 is another pointer variable which is holding the address of b, just like this. Okay, now what is the expression given here? Star P2 minus star P1. Star P2 minus star P1. First of all, what is meant by star P2? P2 is nothing but 3000 memory location minus star P1. P1 means 2000 memory location. So contents inside 3000 memory location minus content inside 2000 memory location. So this is nothing but 20 minus 10. So 20 minus 10 value is 10 here. Clear? So in the output, this is going to display you 10 clearly. Okay, just like this. So now I'll consider another example involving multiple data types. Okay, so hash include stdio.h, the header file is included first. Okay, and inside the main function, I will consider multiple data types like char ch is equal to small a, comma, star cptr, int a is equal to 100, and here I'll use iptr. And next, consider another data type which is floating point type. Float b is equal to 10.75. Okay, and I'll use another pointer variable like star fptr. Okay, now we can write like this, cptr is equal to address of ch. Okay, and similarly iptr is equal to address of a, and fptr is equal to address of b. Now we can simply print the content just like this, printf. Okay, so how can we print percentage c, percentage d, and percentage f, the corresponding values? Okay, so here we can write like this, star cptr comma star iptr comma star fptr. Okay, just like this. Now the moment we write program like this, let's see how this is going to work. First of all, so first one is ch is equal to a. Now it is going to create a memory location for variable ch. So just like this, ch, and it contains a. Okay, so consider the address of ch is let us suppose 2000 memory location, and star cptr. So from this particular statement you can see cptr is a pointer variable. Okay, and this pointer variable is clearly holding the address of ch. So this is going to be 2000, and currently the cptr is pointing to the address of ch. Next, a is equal to 100. You can observe a is another variable and its value is currently 100. Okay, so let us suppose its corresponding address is located at 3000 memory location. Now iptr is a pointer variable. From here you can observe the working of iptr. iptr is currently holding address of a, which is 3000 memory location. Okay, and similarly b is another memory location and its corresponding value is 10.75. Okay, now this has got a memory location like 4000, and fptr is the corresponding pointer variable which is holding the address of B. Okay, so this is clearly FPTR pointing to the address of B. Now the moment it is printing star CPTR, star CPTR means content that is pointed by CPTR. CPTR is currently pointing to this memory location. Star CPTR means content inside 2000 memory location, which is A. So A will be displayed as output. Okay, and then star IPTR. IPTR is currently holding 3000 memory location, and star IPTR means contents pointed by IPTR. So that is 100 will be displayed. And then star FPTR. FPTR is currently pointing to this memory location, and star FPTR means content that is pointed by FPTR, which is 10.750000 like this, a floating point value, isn't it? So this is the corresponding output. Okay. Now consider this program. First, include the respective header file. Okay. And then inside the main function, first consider a couple of variables of integer data type, like a is equal to 100 and b is equal to 300. Okay. Now also consider integer pointer variables. So first one is star p1, second one is star p2, and third one is temp, which is temporary variable of integer data type, direct variable. Okay. So consider p1 equal to address of A, p2 is equal to address of B. Okay. Now consider temp equal to star p1, star p1 is equal to star p2, and then star p2 is equal to temp, just like this. Now finally we can display value of A and B here. So A is equal to percentage D slash T, and then again here we need to print B value similarly. So B is equal to percentage D slash N. So we are printing A comma B values respectively as output. Okay. So this is the program. Let's see how and what is the corresponding output that is displayed by this particular program. Okay. So first consider A is equal to 100. Okay. And then B is equal to 300. So A is a memory location which is currently holding a value of 100, and B is another memory location which is currently holding a value of 300. Okay. So P1 equal to address of A. For example, A is having an address like 2000 and B is having an address like 4000, for example. Now P1 is clearly given as a pointer variable which is holding the address of A, which means 2000 memory location, okay, is basically stored inside a pointer variable P1, and the address of B, that is 4000, is stored inside pointer variable P2, that is P2 is holding 4000, and you can see P2 is pointing to B. Okay. So now temp equal to star P1. So what is temp equal to star P1? Which means star P1 content is 2000, right? So contents inside 2000 memory location will be stored inside a variable called temp. So contents inside 2000 memory location is clearly 100. Okay. Next, star P1 equal to star P2, which means currently star P1 is equal to star P2. What is star P2? Okay. P2 contains 4000 memory location. Star of 4000 memory location is clearly 300. Okay. So star P1 is equal to 300. which means P1 is pointing to this memory location and its value is now turned into 300. Okay. So then star P2 is equal to temp. This is star P2 equal to temp. What is the temp value? Currently 100, which means P2 is currently pointing to this memory location, and right now this value is getting modified to 100. Okay. So the moment you print A and B values as output, you can see A value is modified to 300. So clearly you can see the output that is displayed will be A is equal to 300 and B is equal to 100. So this is a program to perform swapping between the contents of two memory locations with the help of pointers. Okay. And this is the main logic where you can see this swapping occurring with the help of temporary variable called temp. Okay. So like this. Next, consider this particular code and find the corresponding output. First, include the header file. Okay. So in the main function, consider two memory locations. A is equal to 100, B is equal to 200. And also consider pointer variables like star P1 and star P2. Okay. So P1 is equal to address of A and P2 is equal to address of B. Okay. Now P1 is equal to P2. So finally you need to print %d/t %d/n star P1 comma star P2. Okay, like this. So let's see what is the corresponding output that is displayed by this particular code. Okay, so first consider the memory locations, two memory locations, one is A, the other one is B. A contains a value of 100 and then B is another memory location, it contains a value of 200. Okay, so P1 equal to address of A. Let us suppose A corresponding address is 2000 and B corresponding address is 4000. Okay, so P1 equal to address of A, which means you can see address of A is 2000 memory location and P1 is currently pointing to this memory location. Next, P2 is another pointer variable which is holding the address of B, which is 4000, and P2 is pointing to this memory location. Now writing P1 equal to P2, which means P1 will be holding the value or content that is stored by P2. So P2 value is 4000, right? So which means currently this P1 content will be modified to 4000. So when this is modified to 4000, it means it has to locate or it has to point to 4000 memory location. When it is pointing to 4000 memory location, which means both pointers P1 and P2 are pointing to the 4000 memory location. Now when it is trying to print star P1 and star P2, both the P1 and P2 are pointing to the same memory location and the content that is stored inside this memory location is 200. Hence the output printed will be 200, 200. Okay, just like this. So now consider this particular code. Okay, and in this code I'll use multiple pointers and variables, like consider inside the main function we are considering multiple variables like A is equal to 5, B is equal to 10, C is equal to 15, like this. Three variables. And also respectively we'll consider 3 point variables, star p1, star p2, star p3. Okay, so now clearly p1 is equal to address of A, p2 is equal to address of B, p3 is equal to address of C. So star p1 is equal to star p2 plus star p3. So similarly star p2 is equal to star p1 plus star p3, and finally star p3 is equal to star p1 plus star p2. Okay, so finally you need to print values of A, B, C here. So A comma B comma C values must be needed to print. So this is the entire code. Now let's see how this execution happens here. Okay, first A is equal to 5, create a memory location with a variable name called A and its value is currently 5. Okay, and similarly B is a variable which contains a value of 10 currently, and C is another variable which contains a value of 15 currently. And address of A means, let us suppose address of A is 2000 memory location and address of B is 3000 memory location, address of C is 4000 memory location. Okay, now if you look at P1 equal to address of A, so clearly P1 is a pointer variable which is holding the address of A. Address of A is clearly 2000 and P1 is holding this memory location. Okay, and P2 is equal to address of B, which means P2 is currently holding address of B which is 3000 memory location. Now P3 is equal to address of C. So P3 is holding address of C, address of C is 4000, so P3 will be pointing to this memory location. Okay, so now let's see how this is going to execute each of these statements. Clearly star P1 equal to star P2 plus star P3. What is the star P1 right now is equal to star P2 content. Star P2 content is 10 plus star P3 content which is 15. So this value will be 25. Yes or no? It means P1 value is now modified to 25. Clear? So value pointed by P1 is 25 right now. Similarly, if you go for the next statement, star P2 is equal to star P1 plus star P3. What is star P1 here? P1 is pointing to this memory location and its updated value is clearly 25. 25 plus star P3. P3 is pointing to this memory location, so star P3 is 15. So 25 plus 15 is equal to 40. So which means P2 is pointing to this memory location and its value is clearly 40. Okay. Next star P3 is equal to, you can observe star P1 plus star P2. P1 is pointing to this memory location and its value is clearly 25 plus star P2. P2 is pointing to this memory location and its value is 40. So 25 plus 40 value will be 65. Okay. Now you can observe this value of P3 pointed, okay, that is memory location C containing a value called 65. Now the moment you print the corresponding output, you can observe in the output you are actually printing A, B, C values. So value of A is modified to 25 and value of B is modified to 40 and value of C is modified to 65. Okay, so this is the final output that is displayed by this particular code. Okay, like this. So now we'll write a program in order to identify the maximum value among two given numbers. Okay, so there are two variables containing values, and you need to identify what is the maximum value among these two. Okay, so let's consider here just like this. First, include the respective header file. After including the header file, now inside the main function, you consider two variables. Okay, int a comma b comma max. Max is also another variable I'm considering here. Okay, so first we will prompt the user in order to enter the maximum, in order to enter the values of a and b. Okay, so we'll prompt the user to enter any two values. Okay, so the moment user enters two values, okay, using scanf statement, you can read those two values into variables percentage d, address of a comma address of b. Okay, so now you also require pointer variables because the entire task is done with the help of pointers. So I'm just using here two other variables, star p1 and star p2. Okay, so p1 is equal to address of a and p2 is equal to address of b. Now we need to find a maximum among two values with the help of if else statement, and you need to make use of this pointer variables. Okay, so you can observe here clearly. So to the continuation of this particular code, look at this if else condition. If star p1 is greater than star p2, then we can write max is equal to star p1. In the else case, we can store max is equal to star p2. So finally, we can print the maximum value with the help of a variable that is max. So maximum value is equal to, okay, percentage d, and what is the corresponding variable? Max is the corresponding variable. Okay, just like this. So now let's see how this is going to work here clearly. If you observe, first it is going to display enter any two values. Okay, so whatever values that are entered, they will be stored inside variables a and b respectively. Okay, so I'll consider a is one memory location and b is another memory location upon which you are taking the values. Let us suppose a is holding 10 and b is holding 8. Okay, so and also consider address of a is 2000 and address of b is 3000. Okay, now p1 is equal to address of a and p2 equal to address of b, which means p1 is a pointer variable which is holding the address of a. Okay, clearly like this, and p2 is another pointer variable which is holding address of b, just like this. Now if you look at this particular conditional expression, star p1 greater than star p2, it means p1 is holding this memory location, content inside 2000 memory location is 10, so that is nothing but 10 greater than 8. Condition becomes true, so immediately max equal to star p1. P1 is pointing to this memory location, star p1 means contents inside that particular memory location, which is 10. So max value is clearly modified to 10. So right now you can see it is going to display the output as maximum value. Maximum value is equal to, the max is currently holding 10. So hence it is going to display maximum value equal to 10, just like this. Okay, so now similarly we will consider another program. Okay, in order to check whether entered numbers are same or not. Okay, so user will be entering two numbers and you need to check both these values are same or not. Okay, so let's implement this particular code. Okay, so first include the respective header file, that is stdio.h. Okay, so in the main function, first we can write here int. Okay, consider variable a, and also, okay, consider variable b, and then star p1 as well as star p2 pointer variables. Okay, now at runtime we can read values of a and b. Okay, so how can we read here? We can prompt the user to enter any two values. So once the user enters those two values, with the help of scanf statement, we can read those two values into the variables a and b respectively. That is address of a and address of b. Okay. Now p1 is equal to address of a and p2 is equal to address of b. Okay. So similarly, we need to check whether both are same or not. Okay. So for that purpose, we can write if else statement here. If star p1 double equal to star p2. Okay. In that case, we can say both given numbers are same. Okay. Given numbers are same. Okay. So in the else case, we can write given numbers are different. Clearly, we can write given numbers are different or distinct. Okay, just like this. Now, let's see how this is going to work clearly. So first, we are basically reading any two values at runtime and then storing those two values inside variables a and b respectively. Then p1 is a pointer holding address of a and p2 is another pointer holding address of b. So we'll see here clearly a is a memory location and consider the address of a is 2000. p1 is the pointer currently holding the address of variable a. Okay. Similarly, b is another memory location. It is having an address of 3000 and pointer p2 is another pointer variable which is holding the address of b. Okay, let us consider a and b values which are taken as a 2020. Okay, so a value is 20 and b value is 20. Now if you look at this particular statement, that is star p1 double equal to star p2, which means p1 is pointing to this memory location. Content inside this memory location is clearly 20, so this will be evaluated as 20 double equal to star p2. P2 is pointing to this memory location and content inside this memory location is 20. 20 double equal to 20 condition becomes true, and this is going to display given numbers are same. Okay, so the output that is going to be displayed is clearly given numbers are same. Okay, suppose if you have given another values, like for example A is taken as 20 and B is taken as 120. In that case, 20 double equal to 120 condition becomes false. So it will go to the else block and it is going to print given numbers are different. Clear? So like this, we can write any program that is related to conditional statements with the help of pointers. Now I'll write a program which is using loops, concept of loops. So where, for example, in order to identify the factorial of the given number, okay. So number is taken into a variable called n, and you all need to find out the factorial of that particular number. Okay. So, and you have to use concept of pointers clearly. Let's implement the code related to that. First of all, include the respective header file, that is stdio.h. Then inside the main function, first of all, consider a variable for which you are planning to find out the factorial value, that is int n is a variable, okay, and consider star ptr a pointer variable, and then I is a loop variable which is used to iterate, okay, and followed by fact, and its value is 1 initially. So fact is another variable, isn't it? Now first we will prompt the user to enter n value for which you want to identify the factorial. So we can write here enter any value. So the moment you write enter any value, now using scanf statement we can read that particular value using a variable called n, that is address of n. Okay. And now you can see ptr is a pointer variable which is holding the address of n. Okay. Ptr equal to address of n, isn't it? Now using this ptr, okay, we have to write a loop with help of loop variable I for I equal to 1, okay, and I less than, okay, so I less than or equal to star ptr, because n value is basically stored in a variable, okay, and the n is pointed by a pointer variable ptr, okay. So now you can see fact equal to fact into I, and already the initial value of fact is 1, so fact equal to fact into I, and after performing this, now finally you need to display the fact value, okay, that is final output. So you can see fact is equal to, okay, percentage d slash n, and you can display the fact value which is the result, okay. So clearly this iteration, you can see this is iterating till n, I less than or equal to n. Instead of n I am using star ptr because this is implemented with the help of pointers, and this loop variable is going to iterate from 1 to n, and it is going to multiply with a variable fact, okay. Suppose if you want to modify and include some more pointers here, you can also take another pointer variable which is holding the address of the fact variable, okay, and instead of using this fact you can use that pointer variable again. Suppose a star f, in that case star f is equal to star f into I, clear, and finally you need to print star f value where f is a pointer pointing to the address of a variable called fact. So now we'll be discussing about pointers as function arguments. Okay. So if you remember, call by address or call by reference implementation is done with the help of this concept, where we are considering formal parameters as pointer variables, and actual parameters in the function call are mentioned as address of the variable. Okay. So let's discuss about this particular concept, pointers as function arguments. Okay, so see here, pointers as function arguments. Okay, so let me consider an example of finding the maximum value as when two variables are given. Okay, two values are given as input, and we are going to identify the maximum among two given numbers. Okay, so for that purpose, you can see here, consider including a header file stdio.h. Okay, so now consider finding maximum value. Okay, so name of the function is max, and it is taking two parameters here. First parameter is a pointer variable. Okay, I'm just giving you the function prototype declaration, and the second is also a pointer variable. Okay, and followed by semicolon, because this is a function prototype declaration. Okay, now in the main function, first consider two variables. Okay, so consider variables are a comma b. Okay, now we'll read values of a and b at runtime. Okay, for that purpose, first prompt the user to, okay, enter any two values. Enter any two values. So once the user started entering two values, then we can read them with the help of percentage the address of a comma address of b. Okay, so now you can call the same function, which is max function, by passing parameters as address of a and address of b. Okay, so max of address of a comma address of b. Okay, that's it. Okay, we are just we wanted to find out the maximum among two given numbers. So that purpose, we are calling a function called max by passing the address of a and address of b as parameters. Okay, so now let's implement the function called max. Okay, so that is void max. Max is the name of the function, and now consider the two parameters as pointer variables, star p1 comma star p2. Okay, so integer data type star p2. Now if star p1 is greater than star p2, okay, so in that case we can write simply, okay, or we can consider a variable called t here. So t is equal to star p1 in that case. Otherwise we can consider star p2 and store this star p2 in a variable called t. T is equal to star p2. Okay, so finally we can display here maximum value. Maximum value is equal to, and you can see percentage d, value is t here. T is a variable which contains maximum value currently. Okay, so let's see how this particular execution is going to happen. First of all, in the main function, you're taking two variables, address of A and address of B are passed as parameters to function called max. Okay, so which means you can observe here max is the name of the function and you are calling simply address of A and address of B as parameters to max. So you can observe here A is a variable and its value is clearly, for example, you have given an entered value is 10. Okay. Similarly, the B value that is entered is 20. So in that case, address of A, let us suppose address of A is 2000 memory location, address of B is 3000 memory location. Now address of A is passed as an argument to pointer variable P1. So you can observe P1 is another pointer which is holding address of A, that is 2000 memory location. Now P1 is clearly pointing to this memory location, and then P2 is another pointer variable. This is holding 3000 memory location, and this pointer P2 is holding address of B, right? So now star P1 greater than star P2. So star P1 in the sense 2000 location contains a value called 10. Yes or no? So here clearly star P1 greater than star P2. This is nothing but 10 greater than 20. Condition is clearly false. Since the condition is false, it will go to the else block. So in the else block, T is equal to star P2. Star P2 means P2 is currently pointing to this memory location. Star P2 means 20. Okay. T is equal to 20. And finally, you can observe the maximum value is T value. That is clearly maximum value is equal to T, that is 20. Okay. So it is going to display maximum value as 20 here, like this. So you can observe clearly the formal parameters that are mentioned in this particular code is clearly pointer variables. Okay. At the same time, if you observe the actual parameters that are mentioned are clearly address of the variables. We have passed address of the variables as actual parameters. Okay. So now we'll consider another example, that is concept of swapping, where we are going to swap the contents by using pointers as function arguments. Okay. So here let me implement this swapping related code directly. Okay. So here first I'm including the header file, and now inside the swap function we are making use of two parameters here, int star a comma int star b. Okay. Now int temp is a variable and temp equal to star a. Now star a is equal to star b and star b is equal to temp. Okay. So now in the main function we are going to call this particular swap function. Okay. So consider initial value of variable x is equal to 5 and y value is 8. Okay. So swap of address of x comma address of y are passed as parameters to function swap. Okay. And finally here we are printing value of x and value of y, that is x equal to percentage d slash t, and also you can see y is equal to, okay, y is equal to percentage d slash n and print x comma y values. Okay, so now in the main function you can see x equal to 5 and y is equal to 8. Okay, so and we are passing address of x and address of y as parameters to function called swap. Okay, so x value is currently 5. Okay, and y value is currently 8 in the main function. Okay, and we are calling the function called swap, and by calling function swap we are passing the address of x and address of y as parameters. So consider address of x is 2000 memory location, and address of y is clearly 3000 memory location. Okay, so let's consider here pointer variables now, star a star b. Okay, so clearly star a is a pointer variable, and this pointer variable is holding the address of x, which is 2000 memory location. Okay, and within the function swap, b is another pointer variable holding the address of y, which is 3000 memory location, and b is currently pointing to this memory location. Now writing temp equal to star a. Okay, so temp is equal to star a, which means a is pointing to this memory location, and okay, so star a means it is 5. Okay, next star a is equal to star b. What is contents pointed by b? That is 8. So which means this value is currently modified to 8. Next star b is equal to temp, and temp value is currently 5. So which means b is pointing to this memory location and its value is modified to 5. And once a control returns back to the main function, it is going to print value of x and value of y. So what is value of x and what is value of y here? X value is now modified to 8 and y value is currently modified to 5. You can observe here clearly. Okay, so previous values of x and y are clearly 5 and 8, but the current values are x equal to 8 and y is equal to 5. Clear? So now I'll show you with another example. Okay, I'll just try to write a function called update function, where I'll choose one parameter as a pointer. Okay, formal parameter, one parameter is a pointer variable and another parameter is a normal variable. Okay, so let's see the difference. In this case, consider this particular code. Okay, so hash include stdio.h after including the header file clearly. Okay, now in this update function, let me consider void update is the name of the function, and it is taking two parameters. One parameter is a pointer variable, the other one is a normal variable. Okay, so consider one parameter is int star x, another parameter is a normal variable. Okay, so now you can see star x is equal to star x plus 100. Okay, and you can see y is equal to y plus 100. So this is what update operation that is performed inside a function called update. Okay, so now we are using a main function. Inside this main function, we are going to call this particular update function. So consider two variables, int a is equal to, okay, for example, a is equal to 10 and b is equal to 10. Both values are same. Okay. So now we are calling update function by passing parameters as address of A and the second parameter as variable B. Okay. Now finally print value of A and value of B. Okay. So you can observe A is equal to percentage D slash T and B is equal to percentage D slash N. So I'm printing A and B values. Okay. So let's see how this particular code is going to work. First of all, so initially A and B values within the main function. Okay. So I'll show you here. This is the main function and its corresponding variables that are defined inside the main function are two variables. One is A and its value is 10 and the other one is B and its value is 10. So consider the address of A is 2000 memory location and address of B is 3000 memory location. Okay. But what you are passing exactly is address of A and normal variable B. Okay. It means in the update function, you can observe in the update function clearly, we are taking two parameters star x and y. Okay. X is currently holding the address of A, which means what is the address of A here? 2000, which means X is a pointer pointing to this memory location, and B value is copied into variable Y. Okay, so the exact B value that is copied into variable Y, and now its value is 10 directly. Okay, so later you can see star x is equal to star x plus 100. Okay, so the moment you write like this, what is the meaning of this? Star x is equal to star x. What is star x here? Is x is basically pointing to this memory location, so its value will be 10. So which means 10 plus 100 value is equal to 110. Okay. So X is pointing to this particular memory location. Okay. And you can see this value is 110 clearly. Okay. This value is getting modified to 110. And then y is equal to y plus 100. What is value of y here? 10. So 10 plus 100, you can see value is 110 here also. But this is a memory location for y. Okay. Now once the control comes back after execution of this update function, control comes back and it is going to execute this printf statement. So what will be the corresponding output produced in this printf? A value needs to be displayed. What is value of A here? Is 110. Value of A is clearly 110, 110. Next, what is value of B that is getting displayed? B value is clearly unchanged, 10. Okay, so 10 will be displayed as B, but A value is displayed as 110 because A value is passed as we have passed it as address of A. Okay, so from the main function to the function called update, address of A is passed as a parameter and B value is directly passed. It's not the address, it's directly the value that is passed, and B value is currently copied into variable Y, whereas address of A is copied into variable X. X is the pointer variable. So star x equal to star x plus 100, you can see there the contents are getting reflected into the pointer. Okay, so x is a pointer pointing to a memory location which is A. So the contents inside memory location A is getting updated, whereas y is equal to y plus 100, which means this is going to update the local variable value that is created inside a function called update. And after that, once the control comes back to the main function, now when you're printing a and b values, you are able to get the updated value of a, because a is updated already in the main function with the help of pointer variable star x. Okay, but whereas b value is not updated. Okay, it's basically a copy of b in update function is getting updated, but it is not replaced, or it is not getting reflected back to the main function. Okay, so this is clearly the concept of using pointers as function arguments. Okay. So next one is pointer arithmetic. So how we can perform arithmetic operations like increment operation or addition operation or decrement operation or subtraction operation. So how we are going to perform this type of operations on the pointers. Okay. So for this purpose, let's see pointer arithmetic. So consider an example like this. Int a is equal to 10 and star ptr. Okay, so ptr is equal to address of a. Now let us consider ptr plus plus. Okay, and we are trying to print the address located at ptr. So what will be the output? Okay, so remember, let us consider the address of a is 2000. Address of a is 2000, and also consider size of integer is 2 bytes. Okay, so consider size of integer is equal to 2 bytes. Okay, so in that case, what will be the corresponding output that is displayed for this code? Okay, so very simple. This is ptr plus plus, which means ptr equal to ptr plus 1. Okay, so which means ptr equal to, what is the address of a? You can see 2000, right? So 2000 plus 1. Okay, so it is incremented by one memory location, yes or no? 2000 plus 1, so it is going to be incremented by one memory location. That is, you can see here clearly, when it is incremented by one memory location, this is written as 2000 plus. So what is the size of that one memory location in integer data type? So size of integer we have considered as 2 bytes. So this is nothing but one memory location. So size of integer is nothing but 2 bytes. Hence this is computed as 2002. Okay. So this one is signifying the one memory location, and the size of one memory location is 2 bytes. Hence the answer that is displayed will be 2002. Okay, just like this. So now similarly we'll consider for character data type. Okay, consider char ch is equal to small a, and there is a star ptr here. So ptr is equal to address of ch. Okay, so now let us consider ptr plus plus, and it is trying to print okay, percentage u ptr, percentage u ptr. Now what will be the corresponding output that is displayed here? Okay, so if this is the case, you can observe here clearly. First, ch is a memory location. Okay, and it contains a value that is a, which is a character. Okay, So consider its address is 2000. Okay. Then PTR is a pointer variable which is currently holding the address of CH, that is 2000 memory location. Okay. Now writing PTR plus plus. Okay. This is nothing but PTR is equal to PTR plus 1. And this PTR plus 1 is a memory location. It has to increment by one memory location, and this one memory location is equal to, okay, size of character data type. So we can say this as a size of character data type. Size of character data type is clearly 1 byte. So which means PTR value is 2000 plus 1 byte. This value will be 2001. Okay. So it means it is going to print value as 2001 clearly. Okay. So now let's consider for another data type like floating point data type. Okay. So consider in floating point data type a variable float f is equal to 1.45. Okay. And there is another pointer like star fp. Okay. So fp is a pointer variable. Clear? So fp is equal to address of f. Okay. Address of f. Now when I print here star fp, you will get a value which is basically address, and let us suppose fp plus plus. Okay. And then we will print the address, that is percentage u fp in this case. So let's compute in this particular case. First f is equal to 1.45. So f is a floating point memory location and it holds 1.45. So let's consider its memory location is 2000 memory location, and fp is a pointer variable which is holding the address of f, that is 2000, and like this. Now fp plus plus. Okay. So fp plus plus means fp equal to fp plus 1. So this is nothing but fp. What is fp containing 2000, right? 2000 plus 1. So what is this 1 signifying? 1 is signifying we are incrementing it by one memory location. And how much memory is occupied by that particular memory location? So is equal to size of floating point type. Size of floating point type is 4 bytes, which is nothing but 2000 plus 4, which is 2004. So the output that is going to be displayed here is clearly 2004. Okay, just like this. Now, similarly, we'll consider an example which includes addition operation. Okay, so consider floating point type float f is equal to 1.5675 and star fp is a pointer variable. Okay, so fp is equal to address of f, and fp is equal to fp plus 6. Okay, now what is the address that is currently pointed by fp? Okay, or we can say that particular address we can print directly by writing a percentage u fp. Okay, so in order to find output for this particular code fragment, first consider variable f, and it is currently holding a value of 1.5675. Okay, then fp is a pointer variable. Consider its address is 2000 and fp is currently holding the address of fp, so that is 2000. So now let's see how this is going to be evaluated. That is fp is equal to fp plus 6. So this is nothing but fp is equal to 2000 plus 6, which means incremented by 6 memory locations. How this is going to increment by 6 memory locations is at 6 into size of float. 6 into size of float. So size of float is, it is going to occupy 4 bytes. So 6 into 4 is equal to 24. So which is nothing but 2000 plus 24. This is nothing but 2024. Just like this. Okay. So now similarly we'll consider concept of decrementation on a different data type. Okay. So let's consider an integer data type int a is equal to 10. Okay, and star IP is a pointer variable. So IP is equal to address of a. Now IP minus minus. Okay, so let's try to print the address. Okay, that is a percentage u IP. Okay, like this. So now, first of all, a is a variable and it is currently holding a value called 10. Okay. IP is equal to address of a, which means IP is a pointer variable holding address of a. Consider address of a is 2000. So IP is currently holding address of a, which means 2000. So IP is a pointer pointing to this memory location. IP minus minus. Now let's see how this IP minus minus will be evaluated. This is evaluated as IP is equal to IP minus 1. So which is nothing but IP is equal to, what is the content of IP here? 2000 memory location, 2000 minus 1. So this minus 1 is nothing but the size of the integer data type. Here in arithmetic, pointer arithmetic, whenever you are incrementing or decrementing, it represents you are incrementing by one memory location or decrementing by one memory location. It is not exactly a numerical value according to numbers. It's purely a memory location. So we have to consider the size of the data type for both incrementation and decrementation. So this one is clearly a memory location that is consumed by integer data type. So this is nothing but 2000 minus how many bytes are allocated for this integer data type? Okay, it is 2 bytes. 2000 minus 2 is nothing but 1998. Okay, just like this. So the output that is going to be displayed here is clearly 1998 if the address of A is already given as 2000. Okay. So now consider another example. This time I'll go for floating point type. Float f is equal to 1.678. Okay, comma, consider star fp. Okay, and also fp is equal to address of f. So consider fp is equal to fp minus 3. Okay, so now try to print what is fp here. Okay, so that is percentage u fp value we can print here. Okay, so in order to print value here, first consider f is a variable which is holding 1.678. F is a variable and this variable is currently holding 1.678. Okay, and then what is fp here? So consider address of f is 2000 and fp is clearly a pointer holding the address of f. So fp is a pointer pointing to f. Now fp is equal to fp minus 3. So what is fp here? 2000. 2000 minus 3. What is 3 here? Okay, so decremented by 3 memory locations, which is nothing but 2000 minus 3 into size of floating point type is 4 bytes. So this is nothing but 2000 minus 12. Okay, so next 2000 minus 12 is 1988. Okay, like this. So finally, the output that is going to be displayed is 1988, given that the address of F is 2000. Clear? Just like this. So now I'll give you a sample code in order to identify or work on this particular concept. Okay. So first include the respective header file. Okay. stdio.h. After including the header file, now inside the main function, first of all, write an integer variable. Okay, int a is equal to 10 and star p1. Okay, p1 equal to address of a. Clear? So given address of a is 3000. Address of a is 3000. Now p1 is equal to p1 plus 5. Okay, and later p1 is equal to p1 minus 2. So finally we are asked to print here the address that is held with p1, which is a pointer variable. Okay, so this is the given question and we need to identify the answer for this. Okay, what is the output generated by this code? So let's see here clearly. A is a variable and its value is currently 10. Okay, and p1 is a pointer variable which is holding address of a. So consider a address is 3000 and p1 is holding 3000 memory location. P1 is a pointer pointing to address of a. Now P1 is equal to P1 plus 5. So you can see here P1 is equal to P1 value is 3000, which is basically address, plus 5 memory locations. So this is nothing but 5 into size of int. So size of int is clearly 2 bytes. We assume 2 bytes in the system. 5 into 2 value will be 10. So this is nothing but 3010 P1. Okay. So later we have P1 is equal to P1 minus 2. Okay. So now P1 is equal to P1 contains 3010 minus 2. So here 2 is nothing but we have to multiply this with size of integer because 2 memory locations it is related. So 3010 minus 2 into size of integer is how much? 2 bytes. 2 into 2 4. So 3010 minus 4 will be 3006. So finally the output that is going to be displayed here is 3006 for this particular code. Okay, just like this. So next one is pointer to a pointer implementation. So what is meant by pointer to a pointer? Okay, so we know already a pointer is capable of holding the address of another variable. But now pointer to a pointer is a variable which stores the address of another pointer variable. Okay, so let me give you the basic definition of pointer to a pointer. Pointer to a pointer. Okay, so here it stores address of another pointer variable. Stores address of another pointer variable. Okay. So that is why the general syntax of this pointer to a pointer. Okay. So consider having a syntax for pointer to a pointer implementation. So syntax is clearly data type double star PTR, and here PTR is clearly a pointer to a pointer variable. Okay. For example, if you want to define multiple pointer to a pointers, okay, so in that case you can write like this: data type space double star p1 comma double star p2 comma so on double star pn. Okay, like this. And you can see all these are all pointers, p1, p2, so on pn. All these are all pointer to a pointers. Okay, so now we will consider an example for pointer to a pointer implementation. Okay, so first consider int a is equal to 10 and star p1 double star p2. Okay, now p1 equal to address of a. Okay, and consider p2 is equal to address of p1. Now let's print here percentage d a in one line. Okay, slash n. Next, similarly, printf percentage d slash n star p1, and similarly printf percentage d slash n double star p2. Okay, just like this. Now you can observe a is equal to 10 here. What is value of a? Currently it is 10. Okay, p1 equal to address of a, if you observe, so which means address of a is 2000 memory location. Okay, and p1 is a pointer variable which is holding address of a, that is 2000 memory location. Okay, now if you consider the next one, p2 equal to address of p1. Okay, so even a pointer variable will have its own address. Okay, pointer variable holds address and also it has its own address, isn't it? So consider p1 is having address 4000. Now p2 is a pointer variable which is holding address of p1, which is 4000. Now we are printing value of a here. If you observe in the output, value of a means directly 10 will be displayed. Next one is printf percentage d slash n star p1, which means what is meant by star p1? p1 is nothing but content which is address, that is 2000. So star of 2000 means content inside 2000 memory location. So content inside 2000 memory location is clearly 10. So this is going to print 10 again. Next, coming to double star p2. So what is double star p2 here? You can observe star of p2 is nothing but 4000. Okay, so what is content inside 4000 memory location? It is clearly 2000. So star 2000, you can see content inside 2000 memory location is clearly 10. So in the output, it is going to display 10 here. Okay. So 10, 10, 10 will be displayed in the output screen. So this is how, multiple ways of accessing the same memory location. First way shows you directly accessing the variable value. Second one is with the help of a pointer. And the third one is with the help of a pointer to a pointer. Okay. So now I'll give you an example similar to this. Consider variable values like a equal to 10, b is equal to 30. Okay. Also consider pointer variables like star p1, star p2. And also consider pointer to a pointer variables like double star ptr1 comma double star ptr2. Okay. So now you can observe p1 equal to address of a. Okay. And p2 equal to address of b. Now consider ptr1 is equal to address of p1, ptr2 is equal to address of p2. Okay. So now if you want to perform an action like this, for example, double star ptr1 is equal to double star ptr2. Okay. And finally, if you are printing value of a and b here, percentage d slash t percentage d slash n, a comma b values, what is the corresponding output printed by this particular code fragment? Okay. So this type of questions are very important in MCQs. Okay. So here a is equal to 10 and b is equal to 30. You can observe a is a memory location and its value is currently 10. And then b is another memory location and its value is currently 30. Okay. So address of a is currently 2000 memory location and address of b is currently 3000 memory location. Okay. So p1 is equal to address of a. You can observe p1 is a pointer variable which is holding the address of a. Address of a is 2000 and p1 is currently pointing to this memory location. Okay. Next one is p2 equal to address of b. p2 is another pointer variable holding address of b which is 3000 memory location, and hence p2 will be pointing to this location like this. Now ptr1 is equal to star address of p1. Okay. So consider address of p1 is 4000 memory location and address of p2 is basically 5000 memory location. Okay. Now ptr1 equal to address of p1, which means ptr1 currently holds address of p1, that is 4000 memory location. So ptr1 is currently pointing to this memory location. Okay. And then ptr2 equal to address of p2. So you can observe ptr2 is holding address of p2 which is 5000 memory location, and ptr2 is currently pointing to this memory location. So next one is double star ptr1 is equal to double star ptr2. So what is double star ptr2? You can see, so writing this is a double star ptr1 is equal to, okay, so double star ptr2. So what is double star ptr2? You can see double star ptr2 contains 5000, right? So which means star of 5000 is content inside 5000 memory location, which is nothing but 3000. Now star of 3000 is nothing but content inside 3000 memory location, which is 30. It means this content is getting modified to 30 here. So finally you are printing value of A and B. When you print value of A and B, you will see the result as 30, 30 in the output screen. Okay, just like this. So now I'll give you another example, and you try to identify what is the output obtained with this particular code. So first include the respective header file, and now inside the main function, okay, consider variables like this. Int a is equal to 5, b is equal to 10, star p1, star p2. Okay, and also you can consider int temp comma double star ptr1 comma double star ptr2. Okay, so also consider here p1 equal to address of A and p2 is equal to address of B, as well as ptr1 is the pointer holding the address of p1 and ptr2 is the pointer holding the address of p2. Okay, so now let's see what is the corresponding action performed by this particular code here. Okay, so consider clearly here. Okay, ptr1 is holding address of p1 and ptr2 is holding address of p2. Okay, so which means now consider writing temp is equal to double star ptr1 double star ptr1 is equal to double star ptr2, and finally double star ptr2 is equal to temp, and finally we are printing value of A and B here. Printf, finally you can write A is equal to percentage d slash t and B is equal to percentage d slash n, A comma B values. Okay, so let's solve this particular code here. What is the initial value of A and initial value of B here? A is equal to 5 and B is equal to 10. Okay, so which means here we can consider just like this, A is equal to 5. Okay, and similarly B is equal to 10. So both these memory locations are having an address, right? For example, address of A is 2000 memory location and address of B is 3000 memory location. Okay, so consider pointer variable p1 equal to address of A. So you can observe p1 is holding address of A, which is 2000 memory location. Okay, and p2 is another pointer variable which is holding address of B, that is 3000 memory location. Okay, so now we are considering ptr1 is pointing to the address of p1. So let us consider p1 is having let us suppose p1 is located in an address of 6000 and p2 is located in an address of 4000. Okay, so now ptr1 is holding the address of p1, which means 6000 memory location, and ptr1 is pointing to this. And similarly you can see ptr2 is another pointer variable which is holding address of p2, which is 4000 memory location, like this. So the moment you write temp equal to double star ptr1, which means this will make a temp to hold double star PTR1, which is nothing but value of 5. Later, double star PTR1 will be holding the double star PTR2 value. Double star PTR2 is nothing but this particular memory location containing a value that is 10. So this is going to be okay. So 10, which means a double star PTR1. PTR1 is pointing to this memory location, and hence this value is modified to 10. Okay. Later, double star PTR2 is equal to temp. PTR2 is currently pointing to this memory location, which is equal to temp, means this value is modified to 5. And finally, value of A and value of B will be printed as 10 and 5. Okay. You can see this is clearly A is equal to 10 printed and B is equal to 5 that is printed. Okay. Just like this. So now we'll be discussing about character pointers and functions. Okay. So how these strings are basically accessed with the help of character pointers, and how you can make use of concept of functions here. So let's discuss about character pointers and strings with the help of functions. Okay. So let's see here clearly an example of character pointer and strings. Okay. So first, let's consider a sample string. Okay. So, for example, char a of is equal to hello. So consider this is the sample string. Now we can access the entire string with the help of a character pointer. So let's see how we can define a character pointer. Is char star p. Here p is a pointer which is pointing to this particular string. Okay. So you can observe here clearly, using for loop or while loop, we can access the entire string with the help of this particular pointer. So first you need to make p is equal to directly a, or you can write address of a of 0. Okay. So now using while loop, we can write like this, while star p not equal to null character. Okay. Star p not equal to null character. In that case, we can print this star p content. So how we can print this star p content is that printf percentage c star p. So after printing a star p content, now p should be incremented by 1. Okay. So you can observe here clearly p plus plus. Like this, we can access the entire string hello. Okay. So let me explain how this is going to be done here. First of all, we are considering clearly a string called hello. Okay. So we can write this is the string here, H E L L O, and this is a null character. Okay. So you can observe this is a of 0, a of 1, a of 2, a of 3, a of 4, and a of 5. Okay. So now we are taking a character pointer, and p is equal to address of a of 0. Okay. So which means consider this corresponding address is 1000. Okay. So next memory location will be 1001. Next one will be 1002. Next one is 1003. Okay. Next one is 1004. Next one is 1005. Okay. So now P is a pointer, right? P is a character pointer and it is currently holding the address of A of 0. So which means 1000 is the corresponding memory location which is pointed by this pointer. Okay. Now, if you look at this condition, star P not equal to null character. So which means content inside star P is H. Okay. H not equal to null character. Condition becomes true. So associated statement will be executed. What is associated statement? Star P should be printed. So when you print star P here clearly, what is the content inside star P? H will be displayed. So in the next iteration, you can see P plus plus. Okay, this is update statement, right? So pointer P will be incremented to the next position. How this P will be incremented to the next position? You can see P will be pointing to this memory location. Okay. So then star P not equal to null character. So which means E is not equal to null character. Condition true or false? Condition true. So next star P will be displayed, that is E will be displayed, and then P plus plus. So this time P will be pointing to the next memory location, that is it contains L. So L not equal to null character. Similarly, condition becomes true and L will also be printed. So like this, even this condition is also true, this condition is also true. So this is going to print a hello. And after this, you can see P is when pointing to this particular memory location, then /0 not equal to /0, that is null character not equal to null character, condition becomes false. So the block of statements will not be executed, and this is the complete output. So this is how we can access the entire string with the help of a pointer, which is a character pointer. Okay, just like this. Now we'll consider a function. So, and we will implement the functionality of finding the length of the string using character pointers. Okay. So the entire functionality should be attained with the help of character pointers. Previously, we have already discussed how we can find the length of the string with the help of arrays. With the help of concept of strings directly. Okay. So now we are going to do the same, but with pointer implementation completely. So let me consider a new function called find. Okay, we are going to find string length. So name of the function is mystrlen, mystrlen, and the entire string is pointed by a pointer, which is a character pointer. Okay, so let's see here, character pointer char star p is the corresponding pointer. Okay, and now using this function we have to implement this length of the string. Okay, so suppose if you want to display the length of the string, you can display here itself. Okay, or if you want to return the length of the string, in that case we can consider a return type of this function as integer. Okay, so in this case right now I'm implementing just length of the string and immediately displaying it. Okay, so you can observe here clearly. First consider another pointer. Okay, char star t. Okay, and t is equal to p. So now we need to iterate p such that it is going to reach till the end of the string, that is null character. Okay, so we can write like this, while star p, okay, while star p not equal to null character, star p not equal to null character. So in that case we are going to just increment the value of p. Okay, not equal to null character. Till that point we are just incrementing p value. Okay, that is pointer is pointing to the next memory location. So once it reaches the null character, this conditional expression will be evaluated to false and the associated statement will not be executed. Okay, so now we can directly display length of the string. We can directly display length of the string as percentage d. Okay, here we can write p minus t, p minus t, just like this. So this particular mystrlen function is going to find the length of the string and it is going to display the length of the string like this. Okay, so let's see how this is going to perform this particular action here. First, consider we are going to call this function like mystrlen in the main function. Inside main function we are calling this particular function. Okay, so let us suppose the string that is passed here as part of this is suppose hey is this string. Okay, we are calling like this. Then what happens the moment you are calling this particular function by passing a string like this, then you can observe p is a pointer, character pointer, which is capable of pointing to this particular string. So you can observe here this is going to be the string h e y is the corresponding string, and here there is a null character. Okay, and clearly p is a pointer, which is a character pointer pointing to the base address of the entire string. So for example, you can see the base address of the entire string 2000 is a memory location, then next one is 2001, this is 2002, and this is 2003. Okay, and a character pointer is clearly pointing to the base address of this entire string, just like this. Okay, so now we are declaring another character pointer char star t, and the t is equal to p here. So which means t is another pointer which is still pointing to the base address of where p is pointing to. So you can observe t is also a pointer pointing to this memory location. Okay, so now you can see star p not equal to null character. So what is star p not equal to null character? You can observe p is pointing to this memory location, and star p means clearly h not equal to null character. You can observe clearly h not equal to null character, which means condition true or false. Condition is clearly true, and p will be incrementing to the next memory location. So you can observe here p is incrementing to the next memory location. So in the next iteration, again star p not equal to null character, e not equal to null character, condition true or false. Okay, condition true. So since this condition is true, now you can observe p plus plus. That means pointer p is incremented to the next memory location. So that is y. Y is not equal to null character. Okay, so y not equal to null character, condition becomes true, hence p plus plus. Again this pointer p will be incremented to the next position. Now this time p will be pointing to this one. Okay, so at this point you can see null character not equal to null character. In this iteration, null character not equal to null character, so condition becomes false, and associated statement will not be executed. Now printf statement will be executed. In this printf statement you can see p minus t. What is this meaning of p minus t? P is currently pointing to 2003 memory location, and t is still pointing to 2000 memory location. Okay, so which means this is nothing but 2003 minus 2000, which is nothing but 3. So this is going to display value of 3 here. So which means clearly you can observe here output produced is 3. Okay, output produced is 3, and you can also understand here the string contains only 3 characters. Yes or no? String contains clearly 3 characters. So just like this, we will be able to perform finding of the string length with the help of pointers. Okay. So now let's see another function. If you remember strcpy function. Okay. So in case of strcpy function, the second string is going to be copied into the first string. Yes or no? So for this, we will consider pointers, and we are going to perform this same action of string copying with the help of pointers. So let's see how these pointers are helpful here in copying the string. Okay. So I'm going to implement my own function, which is my strcpy function. Okay. And this is taking 2 arguments, 2 pointers, I can say. So one is char star p, the other one is char star t. Okay. So 2 character pointers we are considering here. Okay. Now let's implement this particular code. So the first character pointer is currently pointing to the source string. Okay. And the next pointer t is a character pointer pointing to the second string. Okay. So we can say here my strcpy of destination comma source, right? So this I am considering p is pointing to destination string and t is pointing to source string. So the source string should be copied into the destination string. Yes or no? So in order to copy the entire source string into destination, for this purpose we have to clearly understand how this copying operation can be done. So for this purpose, you take the destination string. Here consider t is a pointer, right? So t is a pointer pointing to the source string clearly. Okay. So consider source string is sure. Okay. And this is having a null character at the end. Okay. Now we want to copy this particular string, source string into destination string, which means consider p is a pointer currently pointing to a memory where the memory is capable of holding up to 5. Okay. So an empty string you can consider initially. So now our task is to copy character by character. Okay. How we are going to copy character by character here? First you need to copy this one here, then this particular character must be copied here, this particular character, and this character must be copied here, and finally you have to assign explicitly null character in this particular position. Okay. So let's see how this action can be done. First of all, we need to iterate this particular pointer till it reaches the null character. Okay. So which means you can write here just like this, while star t not equal to null character. Star t not equal to null character. So we need to copy here clearly character by character which is pointed by this t. Okay. So t is currently pointing to s, right? So s should be copied here. So which means you can observe clearly. Okay. So the content pointed by star t should be copied into star p. So here we can write star p is equal to star t. So after copying, you can see in the first iteration s will be copied. Okay. Now, in order to move to the next iteration, T should be pointing to the next character. At the same time, P should be pointing to the next memory location. So, which means we have to increment T by one memory location and also P by one memory location. Okay. So, then what happens is this time T will be pointing to this memory location, and at the same time P will be pointing to this memory location, and same U will be copied into this memory location. In the next iteration you can see R will be copied here. Okay, so just like T will be now pointing to this memory location and then P will be pointing to this memory location. In the next iteration you can see here clearly T will be pointing to this memory location and P will be pointing to this memory location, and the same E will be copied here. Okay, and now we need to explicitly mark null character at this position. So in order to append this null character at the ending position, we have to write now star P is equal to null character. Okay, so this will automatically append null character in the last position. Okay, just like this. So next, now we'll consider another example where we can concatenate two strings. Okay, so again here I'll be writing a function where it takes input as character pointers but performs this string concatenation operation with the help of those pointers. Okay, so let's see here clearly. Consider the name of the function as strcat, that is my own version, so my strcat. Okay, so I'll consider here two character pointers. One is char star s1, the other one is char star s2, two character pointers. Okay, so now let's see how we can perform this concatenation operation here. Okay, so first of all understand the concept of concatenation. Okay, so let us consider a string first of all and see how this concatenation happens. Okay, so you can consider s1 is a pointer. Okay, s1 is a pointer which is pointing to string like this. Okay, so for example let me consider an existing string. Okay, suppose re. Okay, and null character here, let us consider like this. Okay, and also there are memory locations available here one by one, but they are not used. Okay, there are contiguously some memory locations here, but they are not used. Okay, so now I want to perform concatenation operation of string s1 pointed by with string character pointer s2 is pointing to this particular string. Okay, so consider like this and here there is a null character. Okay, so let's see how we can perform this concatenation. After concatenation, okay, what is the corresponding result after concatenation? So s1 will be a pointer pointing to a string just like this, re is in this one. S1 is pointing to this particular string sure. And next S2 is pointing to this particular string. So we need to perform concatenation. After concatenation, this string will be added here. Okay, that is NDRA will be appended here, and at the end there should be a null character, just like this. Okay, so in order to perform this particular action, okay, let's see how we can write code in order to perform this string concatenation operation. Okay, so first we need to iterate S1 pointer to this position, yes or no? So S1 pointer you have to move and reach this position. Once you reach this position, then you start copying S2. Okay, it means you copy N here, and you can copy D here, and you copy R here, and you copy A here. Finally, additionally append a null character here. Then you automatically get S1 is pointing to the entire string after concatenation. Okay. So in order to perform this particular action, how we can iterate this first of all? Okay, so is that first you need to move S1 pointer to the end of this string. Okay, S1 pointer must be pointing to the end of this string. So let's see how this can be done here. While star S1 is not equal to null character. Okay, so we are moving S1 pointer to point to this particular position. Okay, so star S1 not equal to null character, till that point you perform simply S1 plus plus. So S1 pointer will be incremented to the next location like this until it encounters a null character. So once it encounters null character, now you have to copy S2 content character by character into the entire string where S1 is currently pointing to. From that position onwards, you start copying S2 content. So this can be done by writing another while loop. Okay, that is star S2 not equal to null character. Star S2 not equal to null character. Now you start performing incrementing operation. So that is you have to increment S1 as well as S2. Okay, yes or no? So let's see here in this case how this S2 is going to be copied. Okay, is that first S2 content needs to be copied into S1. So we can write S1 is equal to S2. So after copying this S2 content into S1, now you need to increment S1 by 1 and S2 by 1. Okay, so S1 should be incremented by 1 position and S2 should be incremented by 1 position. Okay, just like this. S1 incremented to the next position and S2 also incremented to the next position. So finally, after copying entire content character by character from string 2 to string 1, so now you will get up to here. Okay, and explicitly you have to append this null character. For this purpose, you can write simply star S1 is equal to null character. So you can observe sure and then NDRA, together you can see Surendra is the string that is pointed by S1. Okay, so now we need to write a program using the concept of pointers to access the string. Okay, so and we need to check whether the length of two given strings are equal or not with the help of pointers concept. Okay, so let's write this particular code here. First include the header file. Okay, hash include stdio.h. So after including this header file, now inside the main function, let's consider two strings here. Okay, so one is string s1, okay, is equal to, let us suppose, hello, and also I'll consider a character pointer for this particular string star p1. Okay, and similarly I'll consider another string, that is string s2, and world is name of the string. Okay, so name of the string is s2 and the content is world, and p2 is a pointer. I want to associate this pointer to string s2. So for that purpose I can write p1 is equal to s1. Okay, or you can also write p1 equal to address of s1 of 0. Okay, both are same. So p2 is equal to s2. This is nothing but p2 equal to address of s2 of 0. Both are same. So now we need to access the entire string content with the help of pointer and count the number of characters in each string. Okay, so in order to count the number of characters in each string, we require an integer variables, right? For that purpose I'll consider int, okay, a comma b. So first string length I want to count inside a variable a, okay, and the next string length I want to count inside a variable b. So initially I'll consider a is equal to b is equal to 0. Okay, because we are going to update this value of a and value of b later while iterating through these strings s1 and s2. Okay, so let's see here, while already p1 is pointing to s1, yes or no? P1 is pointing to s1. Now we need to iterate p1 such that it doesn't reach the null character, yes or no? We need to iterate. The moment it reaches null character, we stop counting. Okay, so you can see here star p1 not equal to null character. So now we'll increment value of a here, a plus plus, and you can observe the count is currently stored in a variable called a. Okay, and similarly count the number of characters that is pointed by pointer p2. Okay, star p2 not equal to null character. Now we need to increment variable b, so that is b plus plus. Okay, so after counting the number of characters in each string, now we need to check whether the length of these strings are same or not, because the complete value of number of characters in each string are stored in a and b, okay, respectively. So now you can see here, if a double equal to b, we can write both the strings have same length. Okay, a double equal to b, in that case we can say strings are of same length or equal length. Okay, so in the else case we can write strings have different length. Strings have different length. Okay, just like this. So now let's see how this is going to work. First of all, okay, we are taking a string s1 is hello and s2 is hello. Hello. Okay, s1 is hello and S2 is world. Okay, and you can see P1 is a pointer pointing to string S1 and P2 is a pointer pointing to string S2, and initially A is equal to 0 and B equal to 0. Yes or no? So let me draw this clearly. String S1, okay, you can observe the content of string S1 is clearly hello. HELLO, and finally you can see there is a null character here. Then similarly there is a string S2, and this string S2 content is world. So WORLD, null character. Okay, so you can see here P1 is pointing to string S1 and P2 is pointing to string S2, which means we are considering a pointer P1 pointing to string S1 and also pointer P2 pointing to string S2. Okay, so now how we are going to compute number of characters in each string. Okay, so let's see here, initial value of A is 0 and initial value of B is also 0. Okay, so A value is used to count the number of characters in this particular string, and B is a variable which is used to hold the number of characters in string S2. So star P1 not equal to null character. Currently P1 is pointing to this memory location. Star P1 means H. H not equal to null character. Condition becomes true and A value is incremented by 1. So you can observe for this character A value becomes 1. In the next iteration, okay, in order to move to the next iteration here, one thing we have to do clearly, okay, to move to the next location, we have to increment this P1. Yes or no? So P1 pointer must be incremented, at the same time P2 also incremented here to move to the next location. Okay, so these things you need to observe here. Now when P1 is currently pointing to this memory location, E not equal to null character, condition becomes true. Again A plus plus, this time you can see A is equal to 2, and P1 plus plus, which means P1 will be now pointing to this memory location. Again star P1 not equal to null character, condition true. A will be further incremented and A value becomes 3 now. So like this the pointer will be pointing to the next location, and finally it is going to count all these characters 1 2 3 4 5. Value of A becomes 5, and the moment P1 is pointing to the null character not equal to null character, condition becomes false. So the while loop block of statements will not be executed and control will be transferred for this particular loop. Now star P2 not equal to null character, you can observe P2 is currently pointing to this particular string. So since W is not equal to null character, O is not equal to null character, R, L, D, all these characters are counted and B value is also 5. And the moment it reaches null character not equal to null character, condition becomes false. So the block of statements will not be executed and A double equal to 5. Here you can see 5 double equal to 5, condition becomes true, and it is going to print strings are of equal length as the output. Okay, just like this. So now let's focus on writing another code. First we are considering a string, and we need to count the number of vowels in the string using pointers. So everything must be done with the help of pointers here, accessing the string, counting the number of vowels in the string. So these things must be done. So let's see how this can be implemented. First include the respective header file. Okay, and after including stdio.h inside the main function, let us consider a sample string, that is char str of is equal to hello. Okay, so after considering a string like this, now you need to consider a pointer as well in order to point to this particular string, char star p. Now consider p is equal to str. P is currently pointing to where this str is. Okay, so let's count the number of vowels in this string. So in order to count, we require an integer variable, right? We consider this as VC and its value is initially 0. So VC representing a vowel count. Okay, so let's write condition for counting number of vowels here. So you can observe P1 is a pointer which is pointing to that particular string. You can see, so P is the name of the pointer that is pointing to the string called str. So now we need to iterate this pointer P such that we will be able to count the number of vowels inside this particular string. So this can be done like this, star P, if star P double equal to capital A or star P double equal to small a. Okay, because A, E, I, O, U are considered as vowels. Okay, so now again star P is equal to double equal to capital E, logical or. Then so similarly we can write star P double equal to small e, logical or. Star P double equal to small I, star P double equal to capital I, logical or. Okay, now star P double equal to small o, logical or. Star P double equal to capital O, logical or. Star P double equal to small u, logical or. Star P double equal to capital U. Okay, so you can see all the letters are covered or not, uppercase and lowercase of A, E, I, O, U. Okay, so yes. Okay, if the character that is pointed by pointer P is equal to any of these things, so in that case only we are going to increment the VC count, that is number of vowels count. So after that we have to increment this P plus plus. Okay, so let's see here, for this first we need to iterate. Okay, so let's see here clearly. So I'm just only performing this action, and this particular if block should be written inside a loop because it is going to count only for the first character in order to iterate till the end. Okay, so what we can do is we have to enclose this inside a while loop, that is star P not equal to null character. So inside this particular while loop we have to write this code, and in order to move to the next iteration we have to increment this P pointer to the next position. Okay, so this is a while loop, and this while loop contains a if block which is for incrementing the vowel count if this particular condition is met. Okay, so finally you can display the vowel count. Okay, so we can write number of vowels is equal to. Okay, so VC, clear? Like this we can display the number of vowels here. Okay, So you can observe in the main function, you can see p is a pointer pointing to the str, and if that particular pointer is not equal to null character, then only we are performing this action. So loop will be terminated whenever a star p is pointing to the null character, that is at the end of the string. So if at all star p value that is pointed by this pointer containing a memory location, if it contains any vowel, that is capital A or small a, okay, like this. These are different conditions for checking vowel. And once this condition is true, then vowel count will be incremented. Okay. So no matter whether vowel count is incremented or not, we have to move to the next memory location to check the next character in the string. Okay. So for that purpose, we are performing p plus plus. And finally, we are going to display the number of vowels by displaying a vowel count variable value. So next one is pointers and one-dimensional array. How we can access pointers using pointers? How we can access the one-dimensional array? Okay. So let me tell you here clearly. First, consider an array. Okay. So concept is pointers and 1D array. So consider an array of elements here. Suppose 10, 20, 30, 40, 50. Okay. These are the array of elements. Now consider name of the array. Let us suppose I have defined like this. Int a of 5 is equal to, these are the elements given 10, 20, 30, 40, 50. Okay. Now you can observe, consider the memory location allocated for this is 2000, and this is 2002, this is 2004, and this is 2006 memory location, and finally this is 2008 memory location. Okay. So in order to display these elements with the help of array notation, okay, we can write a of I, where I is iterated from 0th location to 4th location. Yes or no? So because this is clearly representing a of 0 memory location, a of 1 memory location, a of 2, this is a of 3, and this is a of 4. Okay. So now, according to this pointer implementation, okay, writing a of 0, okay, so this is clearly equivalent to star of a plus 0. Okay, a of 0 is nothing but star of a plus 0. Next, similarly, a of 1 is equivalent to the pointer notation, that is star of a plus 1. Okay. Next, at the same time, a of 2 similarly is equivalent to writing star of a plus 2. Okay. And so on. A of I can be written as star of a plus I. Star of a plus I. Clear? Just like this. Now, it means you can observe here, for example, star of a plus 2. So how this star of a plus 2 can be done? Star of, what is a here? A is the base address. Okay. A is representing the base address of the entire array, which is 2000, plus this is 2, which means it is incremented by 2 memory locations. Incremented by 2 memory locations. So what is the size of each memory location here? Size of each memory location will be 2 into size of integer. Okay, because all these memory locations are of integer. So 2 into 2 is equal to 4. Okay, this is nothing but star of 2004, because this is going to give you 4, right? So content inside 2004 memory location will be 30 from this array. So this 30, how you can access here? This is nothing but A of 2, content inside A of 2 memory location, just like this. Okay, so similarly, now for example, how to access the address of A of I? Okay, so address of A of I is equivalent to writing A plus I. Clear? So it means if you want to access address of A of 0, this will be equivalent to A plus 0. Okay. And similarly, address of A of 1, this is equivalent to writing A plus 1, and so on, like this. Okay. So let's write a program clearly in order to read and display the contents of the entire array with the help of pointer implementation. Okay, that is, we need to make use of pointers and one-dimensional array concept here. So let's implement this particular code. That is, first include the header file, respective header file, stdio.h. Okay, and now in the main function, first consider an array. Okay, so let us suppose clearly A of 20. Okay, and n is representing the size of the array, and also I is a variable, loop variable, which is used to iterate in this particular array. Okay, so let's see here clearly. First we will prompt the user to enter value of n, okay, which is representing the size of the array. That is, enter size of array, and the size of the array can be taken at runtime with the help of scanf statement, %d address of n. Okay, now we can read those many elements with the help of pointer notation. Okay, so first we can prompt the user to enter those many elements, that is, clearly enter %d elements. Okay, so you can observe n number of elements you have to enter. Okay, so using for loop, how we can enter here? For I equal to 0, I less than n, I plus plus. Okay, so we know that in the array notation, how we write generally? Okay, in the array notation we are going to write address of A of I. So as I told, this is equivalent to writing A plus I. Okay, so the same notation we have to use here, A plus I. Okay, so now we can display those elements clearly one after the other by using star in front of this A plus I. Okay, so let's write here printf displaying elements. Okay, So how we are going to display these elements here? Okay, so that is we can do like this using for loop for I equal to 0. Okay, and then I less than n, I plus plus. Okay, so we can display with the help of printf statement here, printf percentage d slash t. Okay, now we can display by writing star of a plus I, star of a plus I. Okay, just like this. So using which you can access the elements and display them. Okay, so this is how we can perform access of the array of elements with the help of pointer. Okay, we are going to access here one dimensional array with the help of a pointer. Okay, so for example, consider n value that is taken is 3, let us suppose. Okay, then it is going to create only 3 memory locations, 1 2 3. Okay, so let us suppose this memory location is located at 2000, and the next memory location is located at 2002, and the next one is 2004 by considering size of integer as 2 bytes. Okay, so at the same time you can see these memory locations. This is a of 0, this is a of 1, and this is a of 2. Okay, so we are prompted to enter n number of elements, that is 3 elements. Now it is going to iterate from 0 to n minus 1, and the corresponding statement is a scanf percentage d a plus I. So a plus I, in the sense, what is a here? Base address is 2000, right? When I is equal to 0, when base address is 2000, you can see a plus I means 2000 plus 0, which is again 2000. Okay, because 0 into 2 is 0 again. So first element will be stored here. Let us suppose first element entered is 10. Okay, so similarly next element, for the next element you can see I plus plus I value will become 1, and 1 less than 3 condition true. Now this time a plus 1, that is 2000 plus 1, this leads to next memory location, that is 2002 memory location. Okay, because incremented by one memory location here. So the next element will be stored here. And similarly when I is equal to 2, again 2000 plus 2, which is nothing but 2004 memory location. So the next element will be stored in this memory location, just like this. Okay, so finally we are displaying those elements by capturing the content inside that particular memory location by explicitly placing star in front of that. Yes or no? Just like this. So displaying the elements one by one. Now you can see here we'll perform action with pointers while accessing the array of elements. Okay, and let's find out sum of elements in the entire array with the help of pointers. Okay, so I'm going to access the entire array with the help of pointers. Let's see here. In this case, I'll go for compile time initialization directly, sum of elements. So consider header file first in the main function. Okay, so directly consider an array like int a of is equal to 1 2 3 4 5. Okay, so next after storing like this, I is a variable which is used to access the entire array. Okay, and now while accessing then we also consider sum equal to 0. Okay, because we need to add these elements one after the other, right? Okay, so let's see here. This is clearly a of 5. Okay, it automatically counts compiler and it is going to store. Yes, there are 5 elements inside the array, right? So in order to compute sum of elements here, write down this loop for I equal to 0, I less than 5, I plus plus. Okay, so sum plus is equal to, you can observe, star of a plus I. Okay, star of a plus I, and finally you can print the sum value. Yes or no? Finally you can print sum is equal to percentage d slash n. Sum value can be displayed like this. Okay, just like this. Now let's see how this is going to work clearly. A of 5 is equal to 1 2 3 4 5. Okay, so first we are going to create contiguous memory locations, that is 1 2 3 4 5 elements are stored in those locations. So this is clearly a of 0, a of 1, a of 2, this is a of 3, and this is a of 4. Okay, so consider their corresponding memory locations like 2000, then 2002, because we are considering integer data type, next 2004, 2006, and 2008. Okay, now I is equal to 0, 0 less than 5. Condition true or false? Condition true. So once this condition is true, the associated statement will be executed. When it is executing associated statement, this is sum is equal to sum plus star of a plus 0. What is a here? 2000. 2000 plus 0 is nothing but 2000. Star of 2000 is nothing but 1. Okay, this is equal to star of clearly 2000 memory location. So content inside this memory location will be 1. So 0 plus 1 value will be 1, just like this. Next, similarly, I value is incremented by 1. I value this time becomes 1, and this is going to be sum is equal to sum plus star of a plus 1. Okay, this time a is 2000 plus 1. Okay, which means incremented by one particular memory location. When it is incremented by one memory location, you can see sum value is basically 1. Latest value of sum is 1. 1 plus star of 2000 plus 1 incremented by one memory location, that is 1 plus 2, value will be how much? 3. So just like this, each and every element will be added. So 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 4 is 10, 10 plus 5 is 15. Just like this, using this particular loop, we can add element by element. Okay, just like this. So now we will consider similarly how we can access two-dimensional arrays with the help of pointers concept. Okay, so it means pointers and 2D arrays. Okay, pointers and 2D arrays. So just similar to the previous concept of pointers and 1D arrays, here there are two dimensions, right? One is for row, the other one is for column elements in each row. Okay, so now what is the equivalent thing for address of a of ij? Okay, so address of a of ij is equivalent to star of a plus I plus j. So these both are equivalent. First thing you need to consider is this one. And second one is whenever you want to display the content inside that particular memory location, that is a of ij, So what is the equivalent representation with the pointers? If you want to represent A of ij, so then clearly this is equivalent to writing star of A plus I plus j. Okay, just like this. So this is pointers corresponding representation of the two-dimensional array. So it means for reading two-dimensional array, you require this notation. For displaying two-dimensional array content, we require this notation. Okay. So just like this. Clear? It means I'll show you clearly with an example here. Consider int a of 2, 4. Okay. Is equal to, let us consider the elements are 1, 2, 3, 4, 5, 6, 7, 8. Okay. So let's see how this is going to be represented in the memory part. Okay. So there are totally how many rows here? Okay. There are totally 2 rows. And how many columns are there? 1, 2, 3, 4. 4 columns are there. Yes or no? So you can see this is 0th row and this is first row, and these are the column elements 0, 1, 2, 3. Okay. And you can observe the content that is stored inside these memory locations are 1, 2, 3, 4, 5, 6, 7, 8. Okay. And if you observe their corresponding memory locations, so consider this memory location is 2000 memory location. So this is 2002, and this will be 2004, and this will be 2008. So 2006. Okay. So we are considering 2 bytes for integer memory location here, and then this will be 2008. This is 2010. This is 2012, and this is 2014. Okay, just like this. Now, if you observe their corresponding memory locations, so let's suppose address of A of 0, 1. Let us consider this element. Okay. So address of A of 0, 1 means we are referring to this particular address 2002. Okay. So as I told, this is already equivalent to writing star of A plus 0 plus 1. Okay. So the single star in the two-dimensional array does not matter, first of all. Okay. So writing single star doesn't make any difference in a two-dimensional array. Okay. So that is why clearly we can neglect this, and A is representing the base address. Base address of this particular array is clearly 2000. So 2000 plus 0, we are not moving to the next row. We are currently in the same row, plus 1. This is, we have to increment it by one column element. So this is nothing but 2000 plus 1. Increment it by one column element, which is nothing but 2000 plus this one is representing 1 into size of integer. So what is size of integer here? 2 bytes. So that is nothing but 2000 plus 1 into 2. So this is nothing but 2002. So clearly 2002 memory location we are accessing, and you can observe both are having 2002. This is equal to 2002, and this is also equal to 2002 memory location. Okay. So similarly, if you want to represent the exact content, so for that purpose, let us suppose A of 1, 2. Okay. So A of 1, 2 is clearly equivalent to writing star of A plus 1 plus, okay. So you have to include one more star here. Total you will get 2 stars. Okay, this is equivalent to writing star of a plus 1 plus 2. Okay, so first you can see what is this a plus 1. It means base address is 2000, you have to increment to the next row. Okay, so how this incrementation happens, you can see here star of a is 2000 plus 1. Okay, in each row how many common column elements are there? Okay, in each row how many column elements are there? There are 4 column elements, right? So this is nothing but 1 into 4 into size of integer, okay, plus 2 here. So you can observe here what is size of integer clearly. Size of integer is 2 bytes. So 4 into 2 is 8. So 2008, and the moment it reaches 2008, then again you have to add two column elements. So which means 2 into 2 equal to 4 bytes. So 2008 plus 4. Okay. So which is nothing but 2012. So finally you can observe star of 2012. Okay, because in a two-dimensional array, one star does not matter. So star of 2012 is nothing but content that is stored inside 2012 memory location, which is nothing but 7. Okay, a of 1 2 is also 7. Yes or no? Just like this. So now let's write a program which is going to consider this concept of pointers and two-dimensional array in order to read the elements and as well as display the elements in a two-dimensional array. Okay, so reading and displaying clearly using pointers. Okay, so here also we will consider a sample two-dimensional array. Okay, so let us consider int a of 2 4 is equal to clearly 1 2 3 4 5 6 7 8. Okay, and in order to iterate this entire 2D array, we require two loop variables. So one is I, the other one is j. Okay, so using I, variable I, we can access the row wise, and using j you can access the column elements within a row. Okay, so let's display here clearly. We are going to display the elements one by one. Okay, so display elements. Now to display elements, first write the outermost for loop. Okay, for I is equal to 0, I less than 2, I plus plus. Okay, next similarly for j equal to 0. So how many column elements are there? 4 column elements are there. So j less than 4, j plus plus. And while displaying, you can see here printf percentage d slash t. Okay, so display the elements which is using a star of a plus I plus j. Okay, star of a plus I plus j. So after printing all the elements, now it can move to the new line, right? Slash n, using slash n can move to the new line. So this is clearly the inner for loop, this is outer for loop, and this is the main function. Okay, just like this. This is how we can display the elements using pointer notation. Okay. Similarly, if you want to read the elements, okay, again you can read the elements with the help of pointer notation. Okay, so let's see how we can read the elements using pointer notation and display them. So for this purpose, we'll initially consider a larger two-dimensional array. Later we'll read the row size and column size corresponding details. Okay, so consider A of 10, 10 initially. Then consider row size and column size, and then ij. Okay, so first we will prompt the user to enter the order of the matrix. Okay, so or we can directly ask row size and column size. Enter row and column size. So once the user enters the row size and column size, using scanf statement, we can read this row size and column size clearly. Okay, address of row comma address of column. So after reading row size and column size, now using nested for loop, you can read okay, elements into this two-dimensional array. For this purpose, we can actually prompt the user to enter those many elements. Okay, so just write using printf enter percentage d elements. How many elements we are asking the user to enter? So which is equal to row into col. Okay, this many number of elements. So once the user started entering those many elements, we have to read those elements inside this 2D array, right? So I is equal to 0, I less than row, I plus plus, and then again you don't just for reading only, right? So for j equal to 0, j less than column, j plus plus. Okay. So using scanf statement, you can see generally for array notation, we'll write percentage the address of a of ij. So, but here this is pointer notation where we'll write a star of a plus I plus j. Okay. And now for displaying elements, clearly we can displaying elements can be performed just like this. You can write for I equal to 0, I less than row, I plus plus. Okay. Next, similarly, for j equal to 0, j less than column, j plus plus. Okay. Now using printf statement, we can print like this: printf percentage d slash t. Okay. So the elements can be displayed just like this: star of a plus I plus j. Okay. And while printing, you can see printf slash n. Okay, just like this. So this is for displaying elements, and this is basically for reading elements into two-dimensional array using pointer notation.